Good morning, everybody. Welcome to our Friday morning West Coast United States Space Show Time program. I am your host for today. Thank you very much for tuning in. We have a great 60-minute program for you. One or two quick announcements. Dr. Kothari is back with us, this gentleman here, on Sunday, talking primarily about cargo to the moon and why that is essential before humans get to the moon. Dr. Ethan Siegel, who is an astrophysicist, is back with us on Tuesday evening. Sarah Skulls, the journalist, Friday morning. Mark Whittington, another journalist, Sunday with one of his articles. And Greg Autry, who I believe all of you know, is back with us Tuesday evening. And we hope all of you can uh, join us, and we appreciate it. Remember, please, our videos are posted on Substack, YouTube, and the Space Show Vimeo platform. And audio is on the Space Show website along with the Substack website. I'd like to introduce to you our guest who is with us today from Sicily, Italy, Dr. Antonino del Popolo. And he has a great new book out. It is available on Amazon, Extraterrestrial Life. We Are Not Alone. Our guest graduated from the University of Bologna in 1990 with a grade of 110, perfect score, cum laude, defending a thesis on general relativity. He got his doctorate in 1994, defending a thesis on the cold, dark matter model. And his bio is in full on the website, but he has been involved in research and research institutes since then. And now he has this book out about extraterrestrial life. So I'm going to ask Antonio to introduce us to his book and the subject at hand, and then we'll go extraterrestrial hunting with him. Antonio, welcome to the Space Show. It's great to meet you
Thank you.
and to
Thank
have you
you.
on board. Tell us about your book and your work.
Okay, so I will follow just the contents of the book and have a summary of what is in the book. So the first part is speaking just about the how life, from what we know and think, from how life was how it was born. And there are two possibilities. One is the possibility of panspermia, but it is not an idea which is nowadays is followed by many people. This was followed by Carl Sagan, by several other people. Nowadays become Mazinge, and now in nowadays they are following this idea. Also, oil already died. But nowadays, there are not many people who think that there is this possibility. The possibility is that life was born somewhere else in the universe and somehow, brought by comets and so on, reached the Earth. There are many, pros about this theory, and it was introduced mainly by Crick before by Arrhenius many years ago, then by Crick, because according to him, the origin of DNA and so on the Earth take a lot of time, and life on Earth appeared around 600 million after the origin of Earth, after which is 4.56 billion years ago. According to Crick, it was impossible that DNA formed in so short time. So he and other people thought that life was born somewhere else away and arrived on Earth, brought by comets or some other objects. The other idea, which is the standard idea, is that the one of Darwin or Haldane, for example, which is based on abiogenesis. So from the non-living objects, I mean, from chemics, you got uh, living beings. And so the main ideas are fundamentally three: the so-called RNA world, according to which you don't start life from DNA, which has two strands. It has an helix, and it cannot alone create proteins, but it started by RNA, which folding can give rise to proteins and so on. The other idea is, I mean, I will not speak deeply about these things. The other idea is another idea was introduced by a German of Extraterrestrial. It's difficult to pronounce this name, a German who thought that, I mean, the life was born in somewhere where there was some volcano. Water was flowing on the volcano. This theory is named iron sulfur world, and he showed how usual matter, I mean, living matter, or for example, the uh, chemistry I mean, of life could be born from reaction related to pyrite, which was give rise to the energy to change monoxide and dioxide of oxygen into organic matter. And there are some proofs that this idea could be correct, because in the ocean under the sea, so very deep, you can find some vents, some regions from which you have the so-called black smokers, in which you have a lot of life and so on. And the last hypothesis is the lipids world, which is based on other ideas. And the problem is the following: life, in order to have life, you need three things. One, genetics; second, metabolism; and the third, cellularity. So you need cellular. Um, so in the RNA world, you have just the genetics. In the world of iron sulfur, you have both somehow: the genetics, RNA, and cells. And in the world of lipids, people like, for example, Adamala or Zostak from US and other people were able to to have RNA reproduce inside some vesicles, something similar to cells. But somehow we are far away from the building up of a real cell, like we know. I mean, there are a lot of studies and laboratories trying to reproduce a cell, but it is a complicated thing. It will take a lot of time. Moreover, Sostak and Livio published a book very similar to this one. The title in English is Earth Exceptional? Yeah, and I mean, it is almost the same. It deals with the same subjects. Um, in the book, I mean, the book also contains a description of the place in which life could exist. And for example, it starts from our solar system. And in our solar system, we know that Mercury, Venus, and so on, there is no life. There is some doubts concerning Mars. But I mean, in the last period, the hopes that there is life are in that it is located in place like um, the Galilean moons, so the moons of Jupiter, Europa, Ganymede, Callisto, in the ocean. There are some ocean underground, or for example, in the moons of Saturn, like Enceladus and yes, and Titan, for example. But in the future here, there will be some better studies with some, I mean, robots trying to understand if really there is some microbial life in these moons. Somebody has told also it is possible that in like Enceladus or Europe, it is possible that there is um, developed life like fish and so on, but nobody knows things like this. And the other possibility is that life is contained is I mean is present in the extraterrestrial exoplanets. The first one was discovered in reality in 1991, but it is going around pulsars. So in reality, people tell us that the discovery of solar planets of extrasolar planets started in 1995 with uh, uh, 51 Pegasi B. This is an object very close to the star, very similar to Jupiter. It is very strange how it arrived at that position, but there is a theory which is migration and so on. And there is a lot of these objects which are named hot Jupiters, and for sure in those objects there is no life. And so you can, in time, were discovered a lot of objects from these hot Jupiters, big objects, smaller Neptune-like planets, many Neptunes, exoplanets like Earth, or a bit smaller than Earth. Um, there are in these planets, there are some which are habitable, which means habitable means that it is located in the region around the star in which water is liquid, if there is water, obviously. And there are several tens of objects which are in the habitable zone of the stars. Um,
Antonio,
yes.
um, you, you list so many possibilities for the existence of microbial life. Probably Mars might be in there too, especially maybe historically. Why is it so hard for us to find it or to confirm it? I know we haven't visited with robots or missions to most of the places you've mentioned, but we have been to some, and we have great sensors, at least for today's technology. Why is it so elusive?
Why? I didn't understand the last thing. Why?
Why, yes, why can't we find it? Why can't we confirm it? Why can't we say the odds are
Yeah.
now 80-20 that it's there, or something like that?
From the point of view of microbial life, it is difficult because in order to study it, I mean, if you study the exoplanets, they are very far away, and you can study just I mean, you have the star, the light of the star come through if the planet has an atmosphere, come through the atmosphere, and through spectroscopy, you can understand what elements are in the atmosphere. So you can understand if there are biosignatures like, I don't know, water, oxygen, and so on. There are some which are indicate that life is present. Until now, only in one planet, extrasolar planet, K218b, it was observed, this signature. But we are at the beginning. I mean, it is something of 3 years ago. So it takes time. I think that in next maximum 10 years, some of the exoplanets will show that there is microbial life. But if you speak about um, civilizations, that is very complicated because I mean, since 1906, from OSMA project and SETI, uh, Drake and a lot of other people searched using microwaves, then the OSETI also using electromagnetic waves like light and so on. Uh, Nobody has ever received any signal of from some planet and so on. Only one time, I think in 1974 or something like that, there was a signal, and nobody knows really what it is. It is named the WOW signal. It is not clear because it never appeared again. So it is not named the WOW because I mean the guy who heard this signal on the paper wrote this word. So it is difficult for many reasons. One is that uh, the galaxy, for example, is very large and the universe is even larger. And if you do some calculation, for example, concerning our just our galaxies, you can calculate the number of civilizations. Suppose that you have 1,000 civilizations, you can calculate the distance between. It is easy to calculate the distance between them and it is very big. It is very big. I mean, it takes 1,000 of years, so thousand of light years. So you cannot even speak with these people. If you say hello, you have to wait 1,000 years to have an answer. So this is one of the problem, but there are many other problems. Many other problems. This is named the so-called great silence. I mean, because we didn't receive any really any signal, even if from 1960 to till now there were many uh, um, search the SETI, as I told you, SETI and so on, with a lot of telescopes and so on. And what can be the reason of other reasons? I told the distance. Another one, according to Fermi, for example, there is the so-called Fermi Paradox. Suppose you know it. According to this paradox, Fermi was asking during lunch, where is everybody? After he did some calculation and reached the conclusion that there was no extraterrestrial life and so on. But other people like Drake and other obviously didn't think at that time the same. So another reason, there are other reasons, like for example, the fact that this civilization, if they are very advanced, they could transmit not using electromagnetic waves, but I don't know, gravitational waves, something else, and we don't understand how to receive this, to I mean, we think that signals are sent through electromagnetic waves. Or another possibility is, this is the worst, that the civilization lasts very small time. There are some calculations by several people, and civilization like our from now, it should live around 400, 500 years, no, not more. So because of destruction, because of thermonuclear wars, for example, comets, supervolcanism, and so on, there are other theories, for example, the so-called Great Filter. This is another possibility. There was a Russian, his name is Kardashev. He created a scale of civilization, the so-called Kardashev scale, according to which there were three scales, first, second, and third kind of civilization. And the first one is related to civilization which are able to use all the energy of its planet. Second kind are civilization who can use the energy, all the energy of the star, of their star. And the third kind, civilization which can use the energy of the galaxy. For example, our civilization should be, according to Sagan, on the point 0.7 of the scale. And there is a concept named the Great Filter, according to which, before reaching the third type of civilization, something happens, some barrier that stops the civilization and to go on and so on. Or other ideas, there are several others, autarky and so on. However, the most not strange, let's say, the story of the distance, the fact that the communication are not could be different from ours, and the fact that the lifespan of civilization is not so long. These are main ideas.
Antonio, I have a question. When you look at the synopsis of your book from Amazon,
Yeah.
near the end of it, it says recent studies based on star formation, the prevalence of planets, and the potential for life-supporting conditions suggest that technological civilizations have certainly existed in the universe. What studies give such certainty
Yeah.
to that statement?
Okay, this point is related to a research of 2016 of Frank and Sullivan. So there is an equation. It is not really an equation. Drake in 1961, in one conference, to describe the possibility that other civilization existed, used a sort of equation, which is a multiplication of factors. The first factor is the number of the stars which are born each year in our galaxy. The second one is the number of planets for each star. The third one.
Yeah, we're familiar. Sorry, we're familiar with Drake's equation. You don't have to
So
go
I
through all
don't
the
have to.
factors.
So
Yeah.
there are three terms which are astrophysical, and the other three which are biological and related to biology, and the last which is direction of the civilization. What these two guys did was the following. Since we know only the first three parameters and the astrophysical one, and we don't know almost nothing about biology because we were not able to create life on Earth, and we don't know if it is easy or not to have life. For this reason, there is also the hypothesis of panspermia. So they took away the term L, the duration of the civilization, and consider only the terms related to astrophysics and the terms related to biology. And they did some some statistical calculation Uh, and they show it that if the probability of the region of a civilization is not smaller than 10 to minus 24, which is a very small number, this means that in our universe, in the past, in all the story of the universe, because they didn't consider, I mean, the Drake equation is concentrated on the question if exists civilization in a certain time. In this point, from their point of view, uh, they asked the question if there were civilization from the time planets were born till the end of the universe, so in the past and the future, and extrapolating in all this long time, so before the Earth was born and after it will disappear, they obtain a trillion of planets on which there are civilization. There are other people, Baldi, Grimaldi, for example, that did other calculations showing that if life is found in some close planet or not close, there should be other 100,000 planets in which there is life and so on. So this result is based on what we know from astrophysics related to statistics, but there is the unknown of biology. So if we knew a bit more about biology, we were sure about the result. So this conclusion of trillion of civilization is related to statistics and this knowledge. And I mean, it can be invalidated by biology in the sense that if life or civilization, the probability is smaller than 10 to minus 24, their calculation is not valid. But probably, I mean, this value is so small that this probability is reasonable. This is the conclusion comes from the work of these people.
So I have a question. For planets like the Earth or maybe like Mars, what is what's the probability that life evolves on a planet like that?
So on another planet like Earth, what is the probability to have life?
Right.
So they did a calculation also for the case of planets in our galaxy, and they showed that, for example, if the probability having life is larger than 10 to minus 11, which is much bigger than 10 to minus 24, so you will have planets which are inhabited. These kind of planets are, so the habitable planets are of different kinds. So were discovered objects like our Earth orbiting around stars similar to the Sun, and there are also a lot of other objects which are similar to Earth or bigger, which are rotating around other stars, which are red dwarfs. These are the majority, and since they are the majority, it is more probable that life will develop there. But these stars has some problems. In the first billion years, they are very active, and so they can create problems to the formation of life on the planet, and the fact that the rotation of the planet is locked to the rotation. I mean, it is like the moon and Earth.
Hmm.
And so the phase shown toward the star is always the same, and there is one phase which is very hot, the other very cold. So there is only one area of the planet in which life could be born. So you cannot give a exact probability of what is the probability that life exists on just on object like Earth rotating on around stars like the sun. What we know is that in our galaxy, the estimates give at least 6 billion objects like this, which means planets like the Earth orbiting stars like the Sun. So the number is big, and from this, one thinks that the probability should be high. I mean, and in the universe, the number of, if you calculate the number of planets in the universe, the calculation should be around 10 to 22, which means 10 to 9, 10 to 9, 100 billion. So it is a very large number. So the probability that life is not existing is very low. I mean, for believers, if you are a believer and you are Catholic, for example, and think that exists God and create, for example, life just on Earth, in that case, I mean, you can explain. You could think that life is not existing in other planets. But if you are not a believer, the idea that life is not existing in the universe is, I mean, a very strange idea. It is very improbable.
So I took 6 billion and multiplied by 10 to the minus 11th, and I got 0.06, which means, folks, we're all dead.
This is for the civilization and so on. But as I told you, nobody.
On average, we're dead.
Yes, but if you use, for example, the Drake equation, since nobody knows the story of the um, three parameters related to biology, you get numbers very high. I don't know, 100,000 and till 10 to minus 13, which is, I mean, which means zero. We are only the only one existing. So, following this route, you cannot reach I mean, the goal. What one has to do is just to wait in the next years, and using the James Webb Space Telescope and the Future Telescope, look at the atmospheres of these planets and understand if there is on these planets microbial life, and if this will be possible, this will imply that for sure there are civilization and so on. So we have to wait some years to understand how big is the problem, how easy is that life forms somewhere.
So we haven't found
Before,
any planets.
eh?
As far as I know, we haven't found any Earth-like planets around stars like the sun. Although we have found what they call super Earths, which are bigger ones and like
I'm
slightly
speaking
bigger.
about the existence of life or civilization. There are a lot, I told you, there are a lot of objects, planets. As I told you, in the universe, the estimate is around 10 to 22 planets. Okay, so planets rotating stars, there are a lot. And there are a lot
Yeah,
of
that's an estimate, but I know in the exoplanets we've found so far, I don't think there are any the size of the Earth rotating around a sun like
as I told you before, there are a lot. There are a lot, and from the number which were observed, there is an estimate according to which there are 6 billion of planets like ours rotating stars like the sun. This is an estimate, but I mean it is done from the related to the observation. Object like ours, close to ours, rotating object like sun are always observed.
Mhm.
Terry, Sherry, do you
What?
want to jump in?
Yes. What biosignatures are you looking for?
What?
Like a
Biopsy.
nitrogen. What are you looking for? What are you looking for on the spectrum?
Oh, okay. What biosignatures, which means some elements which gives us ideas on the possibility of life. And for example, carbon dioxide, which is emitted by living beings, but unfortunately also by volcanoes and so on. Water vapor is a good biosignatures. Uh, Ammonia, nitrogen dioxide. But for example, if we were able to find methane plus together on a planet, methane, ammonia, nitrous oxide, we were almost sure that life is present there. Chlorophyll, for example, we would be sure that life is present. In the case of K2 18b, as I told before, was found dimethyl sulfur, which is produced by plankton on Earth. Okay, these are the beer signature mainly which are looking for.
You mentioned methane, and we do have measurements of methane on Mars. Do you take that as some evidence of life?
Yeah, there was, some speculation about the story of the methane and so on. But in the case of Mars is a special case in the sense that people now thinks that in the past life was present on Mars. In 1976, for example, Viking 1 and 2 analyzed the Martian soil. They did some experiments. They are named degradation metabolism and biosynthetic metabolism, which means they used some elements and they gave to the soil to see what happened. If the soil build up more complex molecule, and this is the biosynthetic metabolism or the reverse. So what was observed was, for example, that the carbon 14 was transformed in carbon dioxide. So there were two kind of experiment and one was positive, but it was not clear if life was existing or not. But NASA decided to conclude that life was not existing because was not found organic matter on the. But nowadays it is known that organic matter, probably there is a discussion going on in the last years and so on. The organic matter could be destroyed by some salts named perchlorates on the soil of Mars. And moreover, there are proofs of the existence of rivers and so on Mars. So the probability of life in the past is high. And so even this experiment, even if there are some people who believes that this experiment gave positive results for existence of life, other who thinks the reverse.
As
But
far as the current measurements of methane that have been made, within the last 10
I don't,
years, do you know anything about those?
I didn't hear what you were
Oh, I'm
telling.
sorry. Yeah, I'm sorry. The measurements of methane that were made within the last 10 years, it sounds like those may be, you think those may
Yes.
be like spurious, non-biological origin?
Mm,
Highly likely.
Antonio, are you still with us?
I'd like to ask a question if is he as soon as he
On
answers this one.
Jupiter,
Hold on, Sherry. Wait a minute. He's
I
back.
will. I said as soon as he answers.
methane is present on Jupiter, a lot on Saturn, and so on. So it is, and we are sure that there is not life. So the presence of methane alone is not a proof of, life, existence of life. As I told before, there are some biosignatures which are good, would give certainty about the existence of life, but they are precise biosignatures. Methane alone is not a proof.
AJ,
All
you
right, thank you.
something? You're muted, AJ.
Oh, I know. Yeah, in 1953 or around that time, I think Enrico Fermi, you mentioned Fermi Paradox. Enrico Fermi and met with Edward Teller and a couple of other people and said, "Where is everybody?" Now, when they say, "Where is everybody?" they don't necessarily refer to microbial life, I would think.
No,
Is that
they
correct?
refer to civilizations.
Right. Yeah. Okay. So microbial life could still be uh, could still be could still be there, as your thesis says, kind of, right?
Yes, yes.
Yeah.
The question of the civilization is very complicated, as I told, because the distances are very, very big in the universe, and
Mhm.
receive signals from other civilization, even if they exist, even in our galaxy, it is almost impossible. It is very complicated story. So in the future, what we have to expect for the future is to using this James Webb Space Telescope or other, looking to planets to see if microbial life exists. But I don't think in the future we will receive some signal from another civilization telling we are here, because it didn't happen, and probably it will not happen.
Yeah. How is it that the Fermi paradox came in 1953, around 53, but the Drake equation, which I thought that it came about in 62, 63,
In
something like
61.
that, 61. So, I was kind of, I would think that that Fermi paradox, obviously it's a paradox, is paradox based on the high number that Drake equation was coming up with. So that would have come before Fermi paradox, but it's the opposite. So it doesn't make you know historical sense to me. But that's not very important question.
So the question exactly is, repeat, please,
Yeah. Yeah. The repeat. Okay. Yeah. So the
the question.
Fermi paradox is
Yeah.
kind of based on or sort of an answer to a very high number that was created by Drake equation, where with obviously hundreds of
It
thousands
is
of
it is the reverse, in the sense that in 1960 Drake started the Ozma project, and the Fermi paradox came before. Yes, came before, in the sense. I mean,
yeah.
there is a story about this, but I will not tell this story. I mean, there are some calculation. So you have a civilization. This civilization will go to another planet, will build there a colony, and so on. If you do a calculation, you find that it takes around 20 million, maximum 100 million years to colonize all the galaxy. So the Fermi told, since we didn't receive anybody, any spaceship who came here, we are sure that civilization are not existent. existing in our galaxy. This is the idea. I mean, he did some calculation, and I mean, they were repeated by other people also.
Yeah. But that doesn't say anything about microbial life.
No,
Microbial,
no,
yeah,
obviously no.
obviously not. Yeah.
I'd like to ask something a little beyond the Drake equation. Um, the solar system is supposed to be in this big galactic bubble, which means we're not around a lot of stars, and it's like 500 light years to the next big.
The Oort cloud.
Yeah, no, it's 500 light years to the next large group
Okay.
of stellar stars that are grouped together. And if you assume that that big collection of stars did have a civilization that could travel from star to star, they'd be very, very interested in starlight because that's the primary driver of life. And therefore, they wouldn't be interested in us sitting out in a galactic bubble, but they would be moving to the galactic arms where there's lots of stars and lots of solar power so that they could go forth and multiply and, dominate the galaxy. So is there any theory in there that blows up my idea?
That there are some civilization going from place to place and so on in some area. So yes, there are. So I let's tell this thing here. Just one moment. Where I should find this. So there are. Just one moment. Your signature. Okay, so there is one idea I mentioned before related to the Kardashev scale, and this was introduced in 1970 by Dyson, who I suppose you know it was a great mathematician, physicist. He was one of the four who gave rise to the quantum electrodynamics. I mean, he showed something and so on, but he didn't receive the Nobel Prize like the other three, like Feynman and so on. In 1970, he wrote one paper related to the Kardashev scale and to the so-called Dyson spheres. So according to this idea, there are some civilizations, for example, civilization 2, who are able to create very big spherical regions and use all the energy of the star for their use, for what they need. And all the energy which is not needed, which is infrared, is expelled, goes out. In this way, so this idea is if you look in a region in which there is a lot of infrared emission and so on, you could have an idea of the existence of civilizations. For example, there are some examples. For example, in the Boot void, the Booth's void, it is a very large region with a very small number of galaxies. And so in the universe, there are voids, regions with very small number of galaxies. But they are not so big like this. This is very, very big. So there are some speculations that inside this region, this void, there are a lot of Dyson spheres which doesn't allow the light to reach us in this. This is one idea. Or, for example, there are other objects like, for example, the Tabby star or other objects which change there is light fluctuations. There are deep still 20% at a given periodic intervals, and there are several. So, for example, in the Tabby star, in this object, it was shown that probably there is some dust moving around there and so on, showing this. But there is some cases which are not explained. It is not clear what creates these very big dips in the light. So somebody is speculating that in that region there are, as I told, this extraterrestrial will use these Dyson spheres and so on to take energy from the stars and so on.
Yeah, I have a question. If you find biosignatures, what are the next steps? I think you partially answered it by saying James Webb. I was thinking it would probably be James Webb. So there's a two-part question. Are there other telescopes involved other than James Webb? Not only that, but how long does it take from the time that you guys or that someone biosignatures are discovered that are seemingly important enough to train the telescope on? How long does it take between the time it is noticed, I guess discovered, and the time that the telescope is swung around to look at it?
So the telescopes nowadays there is only the James Webb Space Telescope, but in the future, not long future. I mean, another telescope will be built, which is named Ariel. Another one, which is more powerful than James Webb Space Telescope. And so you asked how long does it take to from the time you observe these biosignatures and the time you can go and see if life is really existing on the planets. This is a very long time because I mean the supposing that life exists in one planet closest to us. The closest planet to us is one planet in Proxima Centauri group. There are objects which are orbiting in the habitable zone, and we are don't know if there is life or not. But the distance is around 4 light years. So with 4 light years for light. So if you moves at the speed of light and matter cannot move at that speed, it takes 4 years. But if you use the technology that we have now, it takes thousands of years to go to reach that place.
Yeah, I know that. I did not phrase that question correctly. What I meant was, how long does it take for the order to come? For you have let's say you detected the biosignature, and now you want James Webb to be trained on looking at that area of the sky, right? How long does it take between the time that you notice it and that whoever channels you have to go through to get the James Webb to look at it? How long does it take? I'm thinking probably days, weeks, months. That's the number I'm looking for.
Yeah, I have a question to you. So James Webb see signatures, and after some other telescope look there to see what exactly? To see the microbes or what? What you are asking for?
No, that's not what I'm asking. I'm asking, okay, so let's say it is noticed, right? You found the biosignature, and now you want to tell somebody to have James Webb look at it. How long does it take? So you tell whoever it is you tell, please let the James Webb look at this. How long does it take from the time that you discover it until the James Webb is looking at it? Can it be overnight? Can you just call somebody and say, hey, James Webb, look at this portion of the sky? Or does it take
No,
long?
it takes usually, I mean, the observation are done in period of several months. It looks now then later, 6 months later, or maybe 1 year later. It
Okay.
takes not a short time because
Okay.
I mean to have a clear idea, you have to do several observations.
Sure.
And for a case, for example, K218b, the existence of life there, it is still open. The question still open, and it is 3 years. I mean, 3 years, yes, from 2023, the observation were done. So sometime you get the result. Yes, there is life. Yes, no, there is not. And so there are planet other observation in the future years. So it takes some years.
Antonio, I know we're coming up on our hour, but if you look ahead 5 years, 10 years, is there any plausible technology that would allow signals to get here faster than light speed, like folding space that Kip Thorne has suggested, and some other kinds of theories to maybe dramatically shorten or close in on these massive distances? Do you see anything like that as being realistic in 5 to 10 years out, or maybe 50 years out?
I don't think so. There is only theoretically, there is only one way, uh, and this is related to general relativity. There are some solution of general relativity obtained by a guy from Mexico. There is a metric of general relativity in which you have a bubble of on space times, which I mean is able to move at velocity even larger than the velocity of light. Okay, so this is possible theoretically used because the concept of the fact that you cannot move at velocity larger than the velocity of light, and for massive object you should move at velocity smaller than the velocity of light is not valid for space. Space can move at any velocity it wants. And so it is possible to create, using general relativity, it's possible to create an object, a sort of bubble, on space-times, which moves at a very large velocity. But this is just a theory. To create really this thing is very complicated. It needs some negative energy, some peculiar energy, and so on. I mean, theoretically it's possible, but from the practical point of view, it is, I mean, maybe in 1,000 years, I think, not in 50.
I have
Michael,
a question
yeah,
here. Have you looked at the possibility, though, of life based on other chemical things other than just water and carbon like we have here? I mean, things like ammonia for being instead of water, or on the other hand, maybe silicon-based life at higher temperatures, anything like that. That could be out there too.
No, you understand the question also? Excuse me.
Mhm. Yeah.
May you ask the question? Because
Yeah. I mean, what do you think about other chemistries other than the ones we have here to be a basis of a form of
if
life?
life can be built up on silicon, for example, like this.
Hmm. Yeah, that, for example, yes.
Yeah. So there is even a chapter or a part of chapter speaking about this thing. Carl Sagan was speaking about carbon chauvinism in the sense that people think that life can be only done by carbon. So
Hmm.
there are several people who proposed the existence of life based on an element which is similar to carbon, which is the silicon. For example, you have methane, which is CH4, and you have silane, which is SeH4. It is as a similar structure. So you can think, for example, that silicon could create structures, long polymers like carbon. But unfortunately, silicon and silane, so polysilanes are named, are less stable and even dangerous. They can explode and so on. They are not so, not so good for life as carbon. So this possibility, this is a possibility that has been, explored. But as I told, the most probable is with silicon life. But it is a problem. It is also possible. Another story is the story of the solvents. It is possible that life is not based on water, for example, and there are other possibility could be based, for example, on methane, ethane at low temperature. For example, on the satellite Titan, it is supposed, if there is life, it is supposed that the solvent is not water, but it is methane or ethane. So there are a lot of studies also about this thing, which are the what is the chemical elements that can give rise to life, and it seems that carbon is the only possibility. The silicon is similar, but it has some problems. And concerning the solvent different from water, maybe it could be possible.
Bill, you have a
Antonio,
final question for us?
yes,
Huh?
yes, Antonio. As we conclude here, I just want to get a sense of someone who's going to read your book. You have described a number of ways that life could arise and ways that life could be found. What conclusions do you draw, and what would somebody take away from your book?
The conclusion is that, life exists in the universe, that we will be discovered in probably 20, 10, 20 years, but I'm speaking about microbial life. For what concerns civilization, the probability to have signals from other civilization is very low for some of the reason I told, and the probability to have somebody like a T coming to the Earth or something like, or spaceships come to the Earth, and I think is not believable. I think I'm not. I don't believe. I don't think like Avi Loeb, which for everything he observes for him is a spaceship and so on. And after it is obviously a natural object, a comet or something like that. But obviously, if microbial life exists, it means that with time, there are studies, with time, it will evolve. Evolution is, something, a sort of law. And there is a direction of law, which is through the more complicated structures, and at the end, probably also intelligent life. If microbial life will be found, it is very probable that intelligent life exists somewhere. We don't
Very
know
good.
where.
Right.
Antonio,
Thank you.
love to bring you back on the show down the road to continue this if you're up for it. Do you have another book in the works, or is this it for a while?
Another book for the.
Yes. Are you working on another book to come up?
I have written several, and now there will be one published but it is in Italian. One book whose title is Paradox in Physics, and probably I will work on it with a guy from the Perimeter Institute in Waterloo, Nyashav Shordy, who spoke to work on it to publish in US, Canada, and so on. But it will take time. But it will publish it in next month in Italy.
Love to bring you back on maybe in a couple of months if you're up for it to continue
Okay, yes, sure.
looking for life. And I appreciate your being with us for this hour. And I'm looking for Amazon to get my book here. So
Thank you a lot.
thank you for being with us and for everybody participating. Marshall, John Hunt, John Jossie, Joe, Bill Gowan, Ryan, and Dr. Sherry Bell. We appreciate your questions and being here. And until the next time, thank you very much, Antonio.
Thank you. Bye. Bye.